Hello! Our today's topic is matrices. The first and most important thing about matrices that you need to know is their order, i.e. how many rows and columns does the matrix have. Order is written in brackets where first number is row and second is column. Here you can see examples. So in our first example you can see that the matrix has 2 rows and 2 columns, which means it has an order of 2 by 2. Other example would be matrix such as here, which you can see has 3 rows and 2 columns, which means it has an order of 3 by 2. Important thing to note is when a matrix has 1 row or 1 column, it is called a vector. So here we can have a vector with an order of 1 by 3. Moving forward, another thing that you must know about matrices is transposition, i.e. reversing the order of a matrix, or in other words, interchanging rows and columns. For example, if we have matrix A with an order of 2 by 3, when we transpose matrix A, we have A transposed with an order of 3 by 2. And to do this, you simply reverse rows into columns. Another example would be matrix B with an order of 2 by 2. When you reverse matrix B, you still get a matrix with an order of 2 by 2, but its order is changed, i.e. rows are converted into columns. Lastly, the last thing that you need to know about matrices is symmetric matrices. To identify a symmetric matrix, you need to draw a line from top left to bottom right corner, and line is called leading diagonal. It serves as a mirror image, i.e. all opposite numbers of the line have to be equal to each other. For example, matrix A with an order of 2 by 2 with elements 1, 3, 3, 4. You see that leading diagonal has numbers 1 and 4, and opposite numbers are equal to each other. The feature of symmetric matrices is that they are equal to transposed versions of themselves. So when we transpose our matrix A, we still get the same matrix as we sorted with. Another example, let's say we have matrix A with an order of 3 by 3. You can see that leading diagonal has numbers 1, 5, 1, and all opposite numbers of the line are equal to each other. And if we transpose matrix A, we still get the same matrix. So, matrix A is equal to a transposed version of itself, given that the matrix A is symmetric. Having presented you basics of matrices, now we can move on. Now we will introduce you to addition and subtraction of matrices. You can only add or subtract matrices if they have the same order. For example, here, if we have matrix A with an order of 2 by 2 and matrix B with an order of 2 by 3, which, as you can see, don't have the same orders, and that means we cannot add or subtract them. But, for example, here, if we have matrix A with an order of 2 by 2 and matrix B with the same order, that means they can be added or subtracted from each other. So if we try adding them together, adding the matrices is a very simple concept. That is, you add elements from the same location. So in our example, if we adding 2 by 2 matrices, top left corner element will be obtained by adding top left corner element from matrix A and top left corner element from matrix B, which is 2 plus 6. And we repeat the same operation with all the elements. And as an answer, we get a matrix with an order of 2 by 2 with elements 8, 10, 12, and 14. If we try subtracting them, procedure is absolutely the same. Just instead of adding the elements together, we are subtracting them. And as a result, we get a matrix with node of 2 by 2 with elements -4, -4, -4, and -4. If you have any questions, please leave them in the comment section. We'll try to answer them all. Thank you.